So yeah, let's just get started. Yeah, I'm John from Genesis Block. We do these Clubhouse events once a week. Typically, it's a pretty casual discussion. This is the first time we're actually recording these. And to start off, I really like to get to know kind of like the backstory of the founders that we're talking to. Yeah, Jan, Alan, it'd be great if you guys could just tell us, a bit about your background, your history. Go back as far as you'd like to, as far as kind of, what your story is and kind of what led you to cryptos and cryptography.
Sure. Hi everyone. Let me jump in. Uh, I still remember first time reading about Bitcoin on Reddit when it was at 10 cents, and of course, like a lot of people, I just thought it was an interesting idea, but didn't do anything about it. And then later on, when Bitcoin reached $200, a friend of mine was already very involved in the community, and he was trying to educate me. So he said, "Hey, buy me a latte, and I'll send you one hundredth of a Bitcoin." And so he did. But what really got but I still didn't pile into Bitcoin. What really piqued my interest was when Ethereum came onto the scene. Because throughout my career, I had worked on a number of uh, distributed systems that really stood the test of time, uh, zero downtime, always stayed on. This goal of building a software that would collaborate and be really resilient had always been an interest of mine. So when I saw Ethereum taking that concept further and enabling to join and be part of this world computer, I was just so fascinated by its potential. And so that eventually led to starting Enya with Jan a couple of years ago.
Oh, hey, good morning. This is Jan. Great to have you here. I started out as a physics professor at UC Berkeley, and I was always interested in cryptography and numbers. And something like 8 years ago, I got more and more interested in healthcare, among other things, and I moved to Stanford. And my first exposure to the compute, privacy, and social networking world was a collaboration I did with the Biden Cancer Moonshot. And the goal there was to think of new ways for people to share sensitive data. And that worked out remarkably well. We found that most individuals were very willing to share sensitive data, healthcare data in particular. That then led to an interest in privacy and secure compute and fully homomorphic encryption. Alan and I began to see a number of unmet needs in this intersection of how large numbers of people interact with computers as it relates to any kind of sensitive information, whether it's financial data or healthcare data or location data or anything else. So that's a little bit of the genesis of Enya. And I've been teaching beyond Bitcoin at Stanford in the School of Engineering now for the last 4 years. This year, I had the largest class ever. I had 186 students. So there does seem to be a considerable degree of interest and enthusiasm, certainly from our undergraduate population here.
Awesome. Thanks for sharing. So kind of that's a good segue into Enya. So what was the inspiration for Enya? And is there any kind of story behind the name?
Well, the name. Let me start with the name. Is interesting because both Jan and I are fans of Lord of the Rings, and uh, you know, one day Jan came to me and said, "Hey, what do you think about the name Enya?" I'm like, "Oh, you mean the Celtic musician, singer-songwriter? I love her. I love her music. I've been a fan of hers for many years." And he's like, "Who's Enya?" I was, I was looking up the Elfish dictionary, and Enya actually is machines in Elfish, and I thought it would be a great name for our company.
Yeah, actually means, well, the Elfish dictionary is a little bit inherently complicated. There's multiple, variants and dialects, but the one of the possible translations of Enya is algorithm or computing machine, and so
kind of have Alan's opinion to where I hear Enya, I'm like, oh yeah, great artist. But the kind of tie-in with Lord of the Rings, I think, really resonates with a lot of nerds like myself.
Yeah, and as for the inspiration behind the company, as Jan mentioned, we really saw a lot of potential and unmet needs at this intersection of privacy preservation and decentralization. Because when you bring a lot of people together to interact with a very decentralized software systems, um, we can't just focus on enabling technological capabilities. We got to also think about what are the implications for the participants when they participate, um, whether they're operating one of the nodes or whether they're just using the service, because we are talking about a publicly available decentralized compute system, right? And it's so much easier to think about privacy issues from day one, and address them head on, as opposed to retrofitting a system afterwards, and as we've seen with the traditional internet.
yeah, and for me personally, I'm really curious to see how the internet will play out, in the sense that several billion people now interact with the internet every single day through their phones. And uh, it's really changed how we do a lot of things, whether it's education or banking or how we navigate, how we communicate, how we connect. So all those things are changing very quickly and very significantly. And just about 10 or 20 years ago, when we interacted with a computer, we assumed that we have to divulge a lot of information to that computer to get some benefit. So, for example, we all assumed that if we want a medical diagnosis, we have to send a lot of data to the doctor, and the doctor can then compute on those data and return a result. And so we assumed that there's this inherent requirement for us to divulge a lot of information to get services. But with the new generation of secure compute approaches like fully homomorphic encryption, we can generate data, we can encrypt those data, we can have a untrusted cloud worker compute on those encrypted data, and then send us a result back that only we can decrypt. And in my book, that's a very fundamental shift in how individuals can interact with computers, because we can have those computers do stuff for us, like compute on our data, without having to worry at all about who gets to see those data. And that seems like a sort of really fundamental basic shift in how large numbers of people can interact with cloud computers or doctors or whatever else.
Yeah, thanks for that. And I think just for anyone who's listening now, or anyone who listens to this post event, if you guys could basically describe what Enya is in a nutshell, as far as like the elevator pitch or like a simply put summary of Enya, how would you guys describe this?
Enya provides a set of APIs that developers can use to easily build the type of secure computation capabilities that Jan has just described into their applications, and these applications could be very decentralized in nature.
Or something like drop-in privacy. We want to make it very easy for developers to build tools at the edge that balance privacy with insight.
Awesome, thanks for that. So yeah, I guess that's a good transition into OMG. So, what kind of attracted you guys to take lead and work on OMG Network? What was kind of the key selling point as far as the potential that you guys saw in OMG Network?
Well, OMG really has taken the lead and in trying to figure out how to scale Ethereum. It was one of the first to implement Plasma, one of the first to go mainnet. And there's a lot of hard-earned experience in being the first. Um, and we're seeing now, the need to scale Ethereum is immense. And I think there's a lot of knowledge and experience on the OMG team that is super valuable. And there are very, very few people on the planet who have that kind of experience in that could bring to bear to help solve these immense challenges in scaling Ethereum. Now, going beyond scaling though, going back to what was really intriguing to us about Ethereum is this notion of building a world computer. Um, what you can do in a smart contract today is quite limited compared to what you can do on a PC, um, and which is indicative of how early we are still in building this world computer. It's almost as if we are in the beginning of the PC revolution, where we had a single core CPU, uh, and a lot of focus was really on making it faster and faster and faster so that we can do more. Uh, just like the discussions around the Ethereum ecosystem today, where the discussions on scaling it, making it do more, how do we lower costs? But at some point, we'll also need to start thinking about what does doing more mean? Is it simply just about higher transactions per second? Or is it more than that? Is it about enabling more complex computations that could be performed on this world computer? And we couldn't think of a better team to work with than the OMG team to realize that vision.
Jan?
Yeah, I agree. If you're used to doing sophisticated compute in the cloud, and then you start working on smart contracts, it sometimes comes as a big surprise the large number of things you'd like to do but can't do in the setting of a smart contract. And so we have a little bit of a gap developing between what's possible in a smart contract on the one hand, and on the other hand, what's possible using any number of systems in the cloud, whether it's AWS Lambda or whatever your favorite approach is. And the conversation in the L2 space still seems significantly dominated by either cost or transactions per second, aka scaling. And of course, cost and number of transactions per second are really, really, really important. Anyone who's used Ethereum lately has struggled both with the cost and the fact that sometimes the system is very congested. I still remember CryptoKitties, of course, which had a similar congestion problem with Ethereum. Um, but zooming out from that, zooming out just from cost and transactions per second, I think what the blockchain world really wants is to build things that are completely different and completely new, and really change our thinking about things like, what is the currency? Do we want currencies that are able to govern themselves? Do we want currencies that are able to adapt? And do we want currencies that are able to resist manipulation? If we want things like that, then it's interesting to wonder about the kinds of algorithms those currencies will need to run to evolve and learn and be resistant to attack. And that's just one of the many examples where the kind of things you can do in the setting of a smart contract today is very, very, very limited. And if in the blockchain space, if we really want to get to a world where we have distributed systems running more and more autonomously, then it's interesting to wonder how we allow them to tap into a much richer set of computational techniques, whether it's cryptography or machine learning or whatever else.
Thanks. So I guess that's a good segue into the next topic, which is Quasar. And during the prep call, Alan had a lot of really interesting things to share, and I'd wonder if you could kind of tell us, give us a bit of color as far as what's happening with Quasar and what makes you guys so excited about this technology.
Yeah, we're super excited about Quasar. So first of all, what is Quasar? So that goes back to one of the benefits of being a pioneer in scaling Ethereum is you also become one of the first to run into issues that you need to come that problems that you need to solve. And one of the issues that the OMG team had run into and started working on was this exit window when network users try to take funds out of OMG Network and back to the main chain. They needed to wait for 14 days to this challenge period before they would see the funds on L1, which of course is not an optimal user experience. And the team recognized that and started doing a lot of research around what could be done to eliminate that challenge period so that we could create a much better user experience. And that's what led to the creation of Quasar, which is a form of fast exit that allows a liquidity provider to take on the risk of letting a user exit quote unquote early, um, and so that they could have the funds available in the Ethereum wallet much more quickly. And I know the community has been uh, anticipating the release of Quasar for quite some time, and the code actually had been written and frozen for a while, and we've been looking for an audit firm to audit the smart contracts. And given how much excitement is going on in the blockchain space right now, a lot of audit firms are just slammed, but we're just excited that we finally found one that we really excited to work with, and they have committed to finishing the audit of the Quasar smart contracts before the end of May. So we're super excited about that and can't wait to make that feature publicly available.
Yeah, that ties into this larger emerging need that has to do with how does one connect different chains and different L2 solutions? How does one move funds from one place to another? And how does one connect things that are going on in one chain with things that you want to happen in some other chain? So imagine, for example, an atomic swap that would connect two chains. So if you did something in one chain, then something else would happen with certainty on some other chain. So Quasar is just one special case of that. As we see several more blockchains come online, and as we see several new L2 solutions come online, we're facing a world where we need to figure out how to connect all these things in a way that people like using them, and that are convenient and also easy for developers to use. So strategically, we're extremely interested in questions relating to connecting L2s directly without having to go through L1. So imagine being on an L2 and being able to transfer funds to some other L2. And then, of course, we need to connect all the L1s. So this would be something like Ethereum with Solana or whoever else. So once the dust settles a little bit on the L2 side, I suspect a lot of companies will be dealing with these bridging needs. How does one conveniently, cost effectively, and safely connect all the different chains and all the different L2 solutions?
So just to kind of elaborate a little bit more, could you provide any sort of use case from a user's perspective as far as if I were to try and like transfer funds or arbitrage opportunities, how is this going to be kind of beneficial to users just from kind of a more layman's perspective?
Well, so for example, let's just imagine that a chain specializes, maybe emphasizes NFTs, just as one example. But then you have funds sitting on an L2 somewhere, and you just want to buy this NFT. Do you really want to go from one L2 back to main chain for the L1, then transfer your funds to some kind of bridge on the L1, and then have it show up on the other chain? No, what you'd like to do, presumably, is much more directly transact between those two L2s. And the general problem on some level has already been solved through swapping. In a general swapping scenario, what you're doing is you have two liquidity pools, and you put money in one pool and money comes out on the other side out of the other pool. And traditionally, of course, that's done inside a specific smart contract, but nothing prevents you from running liquidity pools on both sides of an L1, L2 solution. So if you have a liquidity pool main chain side and a liquidity pool L2 side, then nothing prevents you from swapping your way on and off across these different chains. And that's just one example of how one is able to connect L2s directly and L2 to L1 without necessarily having to deal with these long exit periods.
Thanks for sharing that color. So to kind of build on that, something that stands out to me as far as what OMG and Enya is working on is the Ethereum augmentation facet. So why is this significant, in your opinion, to the future of Ethereum?
Well, so over time, there's been a lot of advances in computer science, in the realm of data science, machine learning, statistical analysis, developing highly trained and battle-tested models out there in the world of finance and insurance and digital diagnostics, for example. But given today's constraints of smart contracts on Ethereum, you just simply can't implement these models, bring them on into a smart contract, because you can only deal with integers in these smart contracts, and it will be too expensive to operate them directly on Ethereum. So it seems wasteful and unfortunate that all of these innovations that that we've been the rest of the world have been creating are not available to decentralized applications that are running on Ethereum. And that's why we believe it's so important to work on augmenting Ethereum in bridging these gaps, so that decentralized application developers can take advantage of the advances that have been happening in these fields and not have to reinvent the wheel and try to always stay within the constraints of today's smart contracts.
Well, this is a question with a like super long answer. Sort of Alan has already touched on that. I mean, if you try to divide two floats inside a smart contract, you know that doing basic math in a smart contract is sometimes not so easy. And the important thing is also, given Ethereum's issues in scaling, it's not necessarily the case that we want to pack more and more and more stuff into Ethereum. And yet, somehow, we want to make it easier for developers to tap into this much richer repertoire of algorithms and compute possibilities. And there have been a few efforts to move in that direction. I mean, people, for example, might think of TrueBit and other approaches. And those are examples of directions we're looking into. And so generally, what you have to do is you have to monitor either L2 or L1, and based on what's going on in those chains, you have to then trigger off-chain compute. You have to do so ideally in a verifiable way, and results can then be fed back into the chains, just like an oracle would feed data back into the chains. Of course, doing compute is difficult in the setting of a distributed system for any number of reasons. Most obviously, that the miners all need to be able to agree on things, otherwise they can't mine. And that's one of the difficulties in like introducing complicated compute operations in a distributed system. So, but the L2s on some level solve this problem. They make it much, much easier to shard computation. And L2s are also a really great setting for innovation because you can try things out and see if they work. And the barrier to you trying stuff out in the setting of an L2 is much, much lower than someone trying to fundamentally change, for example, how L1 works. And so that's also exciting for us because we can try stuff out pretty quickly and easily and to see if it works, which again would be much, much more difficult in the setting of main chain.
Thanks for that. So yeah, I think moving on to utility. So you guys, so for me personally, I had to do a lot of research to really understand the impact of lattice cryptography in the context of Varna. It'd be great if you guys could share a little bit more about how lattice cryptography, lattice cryptography interacts with OMG Network and the value it really adds to the network.
Well, I'll let Jan cover the lattice cryptography angle, but at a high level, uh, why is it important to like what's the value of privacy preservation in the context of Varna? And first of all, what is Varna? So Varna is a decentralized exchange that we have built. And you might ask, well, there are so many decentralized exchanges out there already. Do we really need another one? And um, for those who've been following what goes on in the realm of decentralized exchanges, they will be familiar with the notion of front running or the existence of dark forest, where without going into the weeds, it's really a phenomenon where because uh, participants of these exchanges are making the wishes known, like to buy a certain cryptocurrency or to swap a certain pair of cryptocurrencies known on a public blockchain, namely Ethereum, um, they are susceptible to their orders being exploited by bots who would then run in front of them to execute a trade and then sell it back to them at a slightly higher value and profit from that. And there are many other different forms of front running as well. And this is only possible because these orders are known to the public and can be exploited. And that's why protecting the privacy of these orders becomes important, because if these bots don't know what you're trying to buy or sell, then they can't front run you. And that's the value that we bring to the industry with Varna, because Varna is a privacy preserving decentralized exchange using lattice cryptography.
And just to provide some color on lattice cryptography. So if you're not familiar with lattice cryptography, you should definitely have a look. And you should have a look because it's one of the few cryptographic techniques that is thought to be quantum resistant. And it is one of those mathematical things that's very easy to do in one direction and exceptionally difficult to do in the other direction. And lattice cryptography matters to us because it is the foundation of something called fully homomorphic encryption, which allows untrusted cloud workers to compute unencrypted data and return encrypted labels that only people with the right lattice cryptographic private keys can decrypt. That's why it's important to us. And that's why lattice cryptography may also be more broadly important to the blockchain space, because it's one of those asymmetric systems that is quantum resistant. So it may be important also for the future of blockchains.
So does this also prevent bot sniping as well as so a lot of the way that these kind of front-running bots operate is that they kind of are tapping into data in the mempool. So even before it hits the chain, they kind of tap in and they can kind of predict what's going to happen and then they kind of front run you like that. So does lattice cryptography also help prevent these kind of circumstances?
Well, so privacy is a really broad topic. If you look at a particular transaction, there are many different things one could try to make private. But in the setting of an exchange, in the specific use case where you're trying to prevent front running, it depends on how you're setting up the system, and the way the system is set up in Varna. Basically, the lattice cryptography and the fully homomorphic encryption addresses the matching problem. It provides a system where two parties with overlapping interests can discover one another without either party disclosing those interests. So, for example, John, if you like pistachio ice cream and I like pistachio ice cream as well, Varna instantiates a system where the two of us can discover one another based on our shared characteristic of liking pistachio ice cream. Likewise, if you want to sell something at a particular price and I want to buy the same thing at a particular price, our interests overlap, and thus we can get matched. At that point, we can choose to execute our trade through any number of approaches, atomic swap or whatever else. So specifically what Varna addresses is the privacy-preserving matching of two individuals based on shared characteristics that they don't want to divulge.
Great example. Thanks for sharing.
I don't know what ice cream you like, but I'm guessing.
I'm sorry, you could cut out just a little bit there.
Oh, I was making up the pistachio ice cream, John. I have no idea what ice cream you actually like.
Well, either way, it's a very easy example for me to understand, as I'm sure it is for anyone who doesn't have the kind of technical understanding that you guys have. So to kind of follow up on Varna, can you guys share a little bit about how the development is going and what you guys are most excited about?
Yeah, so the guts of Varna are done, and it's been in private beta for a while now, and we've gotten really great input from the community. So we're going through the phase of UX design to make sure we come up with the best user experience possible, and we have a design team who these designers themselves have been active users of a lot of different DEXs out there, so they certainly understand what our users expect and also what the rest of the industry has been doing in terms of user experience. And yeah, so we expect to be able to unveil that in the next several weeks, and we can't wait to see what the team come up with.
Jan?
Yeah, it was interesting to see how people responded to Varna on a technical level. Lots of people were super excited that it was done and worked. But then when people started to use it, they said, "Oh, I have to click, 38 times to do something," and they took it for granted that the underlying technology worked, which was what the engineers were focusing on. And now's the time, given that the underlying technology is to work, is to deal with really, really important user experience issues, such as, oh, why do I have to do 38 things to execute a basic transaction? This really should be much, much easier. Look at Amazon. They sell stuff for a single click. So now's the time to really make the system super easy to use and just also fun to use and intelligible for people.
And it's to my understanding that the new UI is almost ready. Just for sake of the community, can you share kind of a loose kind of timeline for when you expect the new UI to be rolled out?
Well, we're going to keep iterating on the design for a few more rounds. So I say probably. Oh, my team is going to hate me for making public commitments. But I say on the order of weeks is what we're looking at.
Awesome. I'm sure the community is going to appreciate that. Sorry, continue.
No, go ahead.
Yeah, and on the business development side, tell us as much as you guys can as far as the next generation of OMG Network and what that looks like as far as what you're able to share.
That's a really exciting and broad topic, actually, because there's just so much to create, so much to build. I say a key focus is really on augmenting Ethereum and how do we do that. But before we get there, um, we need to we need to add smart contract support to OMG, and we'll be able to talk more about how we do that when we're ready. But the team has been doing a lot of research around that area. Um, the goal really is to one, broaden the appeal of OMG Network as a platform for developers, and two, to pave the way towards realizing this vision of augmenting Ethereum with more complex off-chain compute capabilities.
Yan, do you have anything to add to that?
Oh, no, I defer to Alan with sort of business questions.
All right. And to kind of follow up, something, Alan, you mentioned during the prep call that was really interesting to me was the importance of being able to take the square root in the context of dexes like Uniswap. Why is this significant for OMG Network, and why is this such a key USP?
Well, yeah, I was so when Uniswap announced V3, of course, everyone was paying attention. So I was curious and started reading through the white paper, and just couldn't help but notice how they needed to, uh, like the hoops they needed to jump through to work with the fact that you can only deal with integers in the context of a smart contract today, and so in because you can't really take the square root of a number and have a really a reasonably precise result dealing with only with integers. They resorted to tracking the square roots themselves and when needed square those numbers instead. And that's just one of the many examples that how the hoops that today's smart contract developers have to jump through, and unless to our minds, kind of if you're used to coding on any other platform, would find um, that it's as if your hands are tied in many ways writing smart contracts today. So we really imagine this future where smart contract developers have much more freedom in the kind of math that they want to use and in the kinds of algorithms that they want to develop to bring more innovative DeFi products and other products to market and 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 really serve the needs of billions of users around the world.
Could you give us a little bit more as far as how this would play out as a unique selling point for OMG, or like a practical application to why this would be useful from a user's perspective?
Yeah, it's really going to come down to developers choosing to take advantage of these extended capabilities that we will add to OMG, and that's going to what makes OMG unique, because these applications will only be available on OMG. Now, that said, we're very committed to building in the open and to the open source movement. So if other ecosystem players would like to take advantage of these innovations, I mean, our code is going to be all out there, um, but we'll but this is going to but it might require architectural changes on their part. We can't really speak for other teams, but this is the direction that we're taking OMG in, and that's in really enabling more complex computations, giving developers more freedom, so that they have as many tools on at the fingertips as possible to to create really exciting products for their users.
Yeah, this really relates to why people are in the blockchain space at all. And the fundamental dream has got to be that we want a distributed computer where we can do whatever we want to do in a way that is distributed and censorship resistant and reliant and robust. And just to give one example, what Enya did during COVID is we made it very easy for people to submit symptom data to us, and we computed on those symptom data using something called secure multi-party computation. And we had about 10 million people across 91 countries basically allow us to compute on their medical data, which was very gratifying. But of course, you'd like to do something exactly like that on a blockchain. But right now you can't. And that's just one of hundreds of examples, whether it's in the fintech space or whether it's in the messaging space or healthcare space or whatever else. There's thousands of examples of just like that. And so it's not up to us to necessarily develop those use cases. The way we can have most impact is to make it easy for developers in all those different verticals to all of a sudden take advantage of algorithms they've already developed but have struggled to connect to the distributed blockchain world. So Enya is more about building APIs to make that really, really easy. As opposed to necessarily focusing on any one vertical. I'm just giving the healthcare example because that's what I spend a lot of time on campus. But that's just a sort of personal focus of mine as opposed to something that relates to any other company.
So to perhaps oversimplify that statement, would it be inaccurate to say that, you're basically providing the tool that developers can use to develop solutions instead of providing a kind of pointed solution itself?
No, that's exactly right. So let me give one example. Imagine you're a hedge fund. And imagine you are using very sophisticated algorithms to try to make good decisions. Um, Imagine it being easy for you to write a smart contract that can tap into the compute you're doing anyway off chain and use insights from those off chain computations to reparameterize decisions you're making inside the smart contract. So, for example, you could very quickly update smart contract logic to respond to external events or even to learn as new information arrives. And that's just one example in the sort of fintech space. Exactly. And so you'd like for that developer who's tasked with connecting those worlds to find it very, very easy to do so, hopefully only with a few lines of new code they would have to add.
Thank you. So I guess in conclusion to my portion of kind of asking you guys questions, what would success look like to you as far as the future of OMG Network as a platform is outside of user adoption and token price, which is kind of very surface layer? Yeah, what does success look like for you? And furthermore, what are you most excited about for the future developments of OMG Network that you can share publicly?
Well, I have to say it comes down to developer mindshare. Um, Success for the future of OMG, in my mind, would be for OMG to be thought of as the platform of choice if you want to build if you're building on layer 2. OMG is the first platform that comes to mind because it's the easiest to build on. It gives you the most flexibility. It gives you superpower. It makes you a hero to your users. You're able to build apps that are not possible anywhere else.
Yeah, if you're in the blockchain space, you you sometimes think of blockchains as being mature, but we're probably only at the very beginning of developing blockchains that do really, really interesting things. And if you look at the outside world, 99% of developers in the normal world have not built anything on blockchains. And their first exposure, when they try to do that, they're stunned because dozens of things they take for granted as being easy are suddenly very, very difficult. Storing lots of information, very difficult. Dealing with user login, very difficult. Dealing with the time it takes to get a transaction back. All the things you take for granted in the normal internet world right now are still very difficult. And so there's this big barrier to moving from the traditional internet world to blockchains. And one area that is going to be important, not only for OMG, but everyone else in the blockchain space, is figuring out how to make it very easy for a typical developer in the normal world, in the old world, in the normal internet world, to build the things they want to build on distributed systems. And so if OMG can help with that, that would be my personal definition of success, is just opening the door to a large number of developers who've never built anything on a blockchain, suddenly being able to do so and finding it easy and convenient to do so.
I like that. I really like that. And just to kind of circle back, I'm not going to try and explain it for you, but something that Alan said that really stuck out to me was that right now everyone seems to be kind of hung up on the whole scalability issue, which might be resolved with ETH 2.0. But what OMG Network is, what Enya and OMG Network are trying to build is something that's more sustainable. Can you share a little bit more light on kind of what that means and how you guys see OMG Network providing a solution that's kind of outside of this kind of short-sighted scalability issue?
Well, just to give the engineering perspective, for sustainability of any kind of technology, it's got to be possible for a recent CS graduate to jump into the code base, spend a week or two on the code base, and then contribute in a meaningful way. It is absolutely remarkable to me that the Bitcoin paper was 8 pages long and was the genesis of Bitcoin. But if you look at white papers today, for L2s or new chains, they sometimes hit 100 pages of material that is exceptionally dense. And if you look at code bases today for some of the blockchains or L2 solutions, they are extremely large and technically difficult. And that makes it very hard to find bugs, and it imposes incredible barriers to interested young people to come into the field and immediately start contributing. And to my mind, that's a major problem in sustainability, because we need to attract the next generation of blockchain builders and innovators into the field. And one way to do so is to try to make our code bases as compact and elegant and simple as possible. And that's just from a practical perspective of how do we get thousands or tens of thousands of young developers to jump in and come build with us, as opposed to looking at incredibly baroque, complicated code bases that take a long time to read into.
And that's also important from a philosophical point of view for building trustless, decentralized ecosystems. Because if we end up with code bases that are overly complex, concepts that are super dense and hard for even a trained computer scientist to understand, then we're in a way going back to a centralized model where we're delegating trust to a small group of elites who can make their way around these complex code bases and who understand these 100-page white papers. And mere mortals would get shut out from participating in moving these technologies forward. So I think for the sake of staying true to the ethos of decentralization and permissionless participation in the ecosystem, I think it's super important to make sure that we don't overly complicate the technology, but rather focus on really ease of participation, ease of adoption, and make sure future generations of computer scientists can continue to build on what we're doing today.
John, given our audience, I'm very curious to hear their thoughts and also learn about their questions.
Yeah, so that's a good segue into our Q&A session. Yeah, this took a little bit longer than expected. Yeah, so if anyone from the audience wants to come up and ask questions, please raise your hand. We'll add you up. But again, please do verbally consent to being recorded before you ask your question. It looks like we have a lot of friends here too. Brian from Bitcoin Association of Hong Kong. Nick from Refinable was here earlier, and I think he worked with both of you guys before on a project before. Yeah, anyone from the audience, feel free to raise your hand and come up and ask questions. Otherwise, I've pulled some questions from Telegram as well.
Don't be scared. Ask questions.
So I'm inviting up a couple of people that are friends of GB as well. Yeah, so I guess while we're waiting for people to kind of come up and ask questions, one that we had from Telegram was, how is liquidity created or available on Varna?
Well, that's a great question. Our plans for that is Varna will have its own set of incentives for attracting folks to place orders and provide liquidity on Varna. Because once you've placed an order, your funds will be tied up, and it would be unreasonable to expect people to be willing to do that for free. So there will be a reward mechanism built into the tokenomics design for Varna itself.
Well, so right now, Varna is just doing atomic swaps, which don't require liquidity pools. But of course, having liquidity pools makes the whole system much easier and much more convenient to use. And just like liquidity pools anywhere, people who provide liquidity will have to earn something in exchange for tying up their funds in a liquidity pool. So, but there's any number of good known solutions out there, and Varna will end up with one of those.
So I had a question, and I
Andy,
consent
before
to
you
be
talk, can you consent to being recorded?
I consent to being recorded. It's a little strange. It's kind of a broader question. It's just it really piqued my interest. You're talking about the lattice cryptography and it being quantum resistant. I was curious as to what role you guys see quantum computing playing in this space, and how soon you see that role growing to something substantial.
Well, I'm sure all of us have been watching quantum computing with very considerable fascination. Quantum computing for certain cryptographic techniques has very significant implications because certain math problems that were previously very difficult to solve may all of a sudden become very easy. There is no, as far as I know, there's no immediate dramatic impact of quantum computing for the basic security of contemporary blockchains. So it's not that once quantum computers become more widely available, it's not that current blockchains will, generally speaking, become unsecure because of the techniques they use. But it certainly does mean that it does narrow the set of cryptographic techniques people should be using in general. In terms of when the technology will become available, there's certainly been examples already of certain math problems being solved by quantum computers. But I can't give you any specific timeline or anything. This is really a little bit beyond my area, and it's an area that's being very actively pursued by several companies, and then also, of course, various governments.
Awesome, thank you. I actually had a couple other smaller questions for you. You're talking about the the world computer. I really love that that analogy, kind of like the infinite machine. Because of that, treating this entire system as a computer, there are some pretty significant limitations with transactions per second. I was just kind of curious as to why, not to show any other projects or anything, but why you chose OMG over Solana. Like, what were the advantages that you saw there over another network that might provide similar sorts of like features and benefits?
No, we have a lot of respect for the Solana team, and they've done an amazing job, and we think they are creating a really vibrant ecosystem on their own, with OMG having been very active in championing plasma, and also with a lot of connections with the rest of the ecosystem. We wanted to work on a kind of an open Ethereum oriented ecosystem to really enable the next generation of smart contract developers to build amazing apps. And yeah, we have a lot of respect for Solana for what they've done, and we think there are many different ways to enable developer to give them superpower, and Solana is one of the ways, and what I would believe what we're building with the OMG team is another way.
Awesome, thank you. Yeah, I mean, there's plenty of room for
Yeah.
for everybody really in the space. If you think about how many car brands are there, right, and they're all quite large. So.
Jan?
Oh, sorry, I may have missed you. Yeah, Alan's point about being Ethereum focused was one of the deciding factors. So it's important for us to be trust rooted in Ethereum and closely connected to the Ethereum world. But again, what Solana has built is truly impressive. So there's no right or wrong here. What's fascinating to me personally about the blockchain space is just how much there is to do, and just how early it is. And so there's as you said, there's just a lot of room for many different technologies in many different directions. But this connection to Ethereum was important to Enya.